This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello everyone. Today we welcome Michael Geers to our show. Michael is a front-end developer passionate about user interfaces. He has worked on many e-commerce projects in the past decade. Michael shares his learnings by way of conference talks and by running a site, microfrontends.org. He also has a book in progress on the same topic. Welcome to the show, Michael. So happy to have you here.
My pleasure. Thanks.
So Michael, let's jump right into it. What are microfrontends?
The Microfrontends architecture is a way of dividing an application into multiple parts that can be worked upon independently. So let me give you an example. We are building e-commerce systems, and in our projects, we have different teams working on different parts of the e-commerce system. So we have one team that only does search. We have another team that does the product detail page, and we have a third team that handles the complete checkout process. And all of these teams have their own application, they have their own deployment process, they have their own database and their own front end, and can work independently from each other and only integrate in the front end. So this is what most people call micro frontends or the microfrontends architecture.
So you mean the front end is a piece of the entire vertical slice?
Yes.
So as opposed to just microservices in the past where only the backend teams had the vertical slice, but the front end was one big layer.
Yes, when you compare it to microservices, you can see it as microservices with an integrated UI. So having a UI inside of each microservice and then integrating on the UI level and not on an API level in the backend.
So why is that good? What was wrong with having a monolithic UI talking to many microservices?
Basically the same reasons why you wanted to move from a monolithic backend to microservices apply to the front end as well. So having a monolithic front end at a certain size creates organizational issues. So having 10 or 15 people working on one code base for the front end can become a challenge. And another reason is that when you create vertical slices, which include the user interface and also the database, the business logic, and everything beside it, you are able to have cross-functional teams that are able to work faster because everyone necessary for creating a feature is inside of this team.
Okay, let's take a step back and look at what is the situation before microfrontends. So you have one UI team. What else is part of that team? What are the skill sets that team needed to have?
So in a layered architecture, you have a dedicated front-end team that handles everything in the front-end. So they picked a JavaScript framework, for example, and all of these people build a huge application with this JavaScript framework, and the front-end team gets its data from the microservices underneath it. And in many cases, you have a backend for front-end which aggregates or hides the microservices architecture and delivers the data through the front end as the front end people need it. And you have dedicated people in this microservices that are working on the back end.
Michael, what is the backend for front end concept that you mentioned? What problem does it solve?
So the concept backend for front ends is a way to aggregate data from a microservices architecture so that a front end team could use it. So the people working on the front end don't have to know about how many microservices are there and which microservice is responsible for what. They get an aggregated view through the backend for front end layer that sits between the front end and the backend.
Is that a replacement for the typical way you would do it by using REST APIs?
So a backend for frontend can be a set of REST APIs, but it aggregates and normalizes these APIs for the frontend team.
So how is the interaction between the front-end team and the different microservices team in that case?
So if you're building a feature that only involves one microservice or only involves making one change inside of the front end, everything is fine. So the front end team can make its change and everything is pretty. But if you have a feature, and most features are structured this way, where you need a change on the backend, maybe you need a new field in the database, and the field in the database should also be visible in the front end, then multiple teams have to connect. So the backend team has to make the change, the front-end team has to make the UI adaptation to show the new value, and maybe also the front-end for backend, the interface layer between these two has to be updated to add this data. And talking between these different teams is something that's expensive. And the communication between these teams is something that's very expensive in most companies. Not because it's complicated, but because it takes time. So you have to arrange a meeting, talk to the other team, say that you need a new field. The other team has to put this task in its backlog, and the front-end team has to wait for the data becoming available. And with introducing cross-functional teams or end-to-end teams, where all people from front-end to back-end are inside of one team, you can eliminate this talking to each other, or eliminate the coordination between different teams.
So the driver for Microfrontends sounds like mainly is the team structure. So are microservices a prereq for building microfrontends?
In a certain way, I would say yes. So at least when you build the microfrontends architecture in the way I just described, so having a team that does front end and also does back end, you can do microfrontends only on the front end. So if you're having a large React application, for example, and you want to parallelize development inside of this React application, you can just split the front end and let the back end stay as it is. So it's not a requirement to use a microservices style architecture also in the back end. But most companies that introduce it do it to gain the organizational benefits.
Can you give us some examples of customers that are developing or have developed with microfrontends?
Yes. So there are a lot of e-commerce companies that have adopted this architecture. So there's a European retailer called Zalando, which structured their application in this way. Also, IKEA's new online platform is built using microfrontends approach, but there are also other companies like the sports streaming service DAZN, or the job marketplace company Stepstone, or even bigger companies like SAP. They've created microfrontends library at the end of last year and published it.
I have seen some presentations by Dizon, I think on O'Reilly as well. Are you familiar with their work?
Yes. Luca, the architect from the zone, is very active in this community and shares a lot of their learnings.
So do customers start with microfrontends or is that something that they actually refactor to?
So since Microfrontends is an architecture for scaling development, I haven't seen many smaller or startup companies that started with a Microfrontends approach. So in most cases I've seen the companies had an existing monolith, knew their business model, and then split it into individual parts to grow their development and parallelize their teams.
So we talk a little bit on the team structure that caused the reason to move to microfrontends. We'll talk more about how teams will now be structures with microfrontends in place. But before that, let's continue our discussion on the skill sets that we started. You mentioned that prior to microfrontends, a lot of teams built the UI using JavaScript. What else? What are the technologies that would you expect front end developers to have?
So if you're doing the microfrontends approach end to end, you are suddenly working not only with other front-end developers, but also with back-end developers. You're talking about APIs. And in our projects, I found it very inspiring to see people getting out of their comfort zone. So back-end developers being able to look at the front end or to modify the front end, but the same for front end developers. So front end developers getting closer to the back end. So removing the front end back end gap we introduced over the last years. Another skill every developer should have is similar with the microfrontends architecture. You're now building a distributed system. So you're not the software you are building is part of a larger system, and you have to understand how these parts play together. So what user interface part integrates or interacts with another user interface part from another team, for example.
So, Michael, that means that UI developers can no longer just focus on front end technologies, which is a big complex area in itself, but now have to understand the entire system as well as the fact that it's distributed, which introduces a lot of complexity. So, does this impact their skills, and does this impact the expertise that they have to gather and dilute the functionality in other ways?
So yes, in general, you could say that front-end developers now have more tasks than compared to a pure front-end team. So they're moving from being a front-end specialist to more of a generalist that also knows other parts of the system. Another effect we see in these teams is that you all of a sudden you don't have a team of 10 front-end developers, for example, but you have 2 front-end developers in 5 teams. And these front-end developers are not able to specialize in specific areas of the front-end, like you have one front-end developer who's very good at integration testing, for example, and you have another developer that understands the Redux store very, very well. The front-end developers in these teams have to have a broader understanding because there are, for example, 2 people in a bigger team of mostly backend developers.
Let's continue with the team for a little bit more, and then we'll get to technology. Now, we talked about the front end developers. What impact does Microfrontends have on the back end developers that are now part of the team? Do they have to get additional skills?
You can compare to the DevOps movement, where backend developers were suddenly also required to also acquire tasks that enabled them to run their own infrastructure, for example, on a cloud system. And the same way with Microfrontends, this backend developers now can expand their horizon to the front end. So also understanding what goes on in the front end. That doesn't mean that everyone on the team has to know everything by heart, but the area of the system and the technologies involved are getting broader.
So there's more awareness in this cross functional team in both directions. What about UI design engineers?
Having a good strategy for UI design and having a centralized design system, for example, is very crucial. So in all of our projects, we set up a design system from the start. So all applications use the same UI building blocks for their user interface they create. This ensures that the end product, which is made up of different applications, has a similar look and feel to the end user. So in an optimal world, we would also have UX designers inside of every team. But in our projects, we had one project where we achieved this, and we had enough resources to staff all teams with a UX designer. But you can also have a centralized design team, for example, that builds a pattern library, a style guide that other teams can use. And these designers can support these teams in building user interfaces that feel alike.
What about the role of front end leads in this team structure?
So since they are not talking about one big front end, but have multiple smaller front ends, there's not as much need for having a strong tech lead because you have only 2 or 3 people working on the front end. So the need for having a strong lead decreases, but you still have inter-team topics where all teams should agree upon. So having a common strategy to do accessibility, to do performance testing, for example, is something all teams have to coordinate upon. And in our projects, we have people like, we call them front-end architects, which try to create a common vision across all of these teams.
So now you have front end architects that are coordinating or giving a common vision to multiple teams. How is that typically coordinated?
So the main focus of this microfrontends architecture is having teams being able to run on their own. So having their own systems, making their own technology decisions, and deploying the application. But you definitely need coordination between these projects. But since you don't want to reinvent the wheel, you have the need for exchanging best practices, exchanging information between people from the same profession across multiple teams. So common pattern for solving this is having guilds. So having front-end developers from all of the teams come together weekly, for example, and talk to each other, discuss common topics like how to solve this kind of integration problem or what performance best practices all teams should adopt. And we don't have this only for front-end. We also have this for a specific kind of database, for example, or for search engine optimization, or for doing analytics properly. So you have people from different teams that come together on a regular basis to exchange information.
Besides best practices, I assume there are shared components and shared libraries for, let's say, authentication or monitoring. Is that right? And how are those owned and coordinated and shared?
So in general, we try to avoid introducing shared libraries or shared infrastructure systems because they can introduce coupling. But we also have talked about the pattern library or design system earlier. So this is a shared piece of software that all teams can pull into their application to accomplish a coherent user interface, for example. And there are other topics like how to do authentication. You don't want the user to have to log in with its password and user interface into each individual micro frontend. In this scenarios, we have one team that does the authentication, has the concept of a user, and this team provides the login information, for example, via a JWT token to the other teams. You also mentioned infrastructure, so we also have a common logging service, for example, which is owned and hosted and maintained by one team, and other teams can use this system as a logging service so that not all teams have to build up their own infrastructure.
So you're recommending an approach where there is not one infrastructure team. Each team that is owning a micro frontend also owns additional pieces or additional services that other teams can leverage. Why is that? What is wrong with having an infrastructure team?
So both approaches are valid, and I see many companies having dedicated infrastructure teams. So both approaches are valid, and I've also seen a lot of companies having dedicated infrastructure teams. In our projects, we try to have all teams centered around a specific customer focus. So we have the search team, for example, which solve the searching need from the customer, and a horizontal team, like for example, an infrastructure team, doesn't directly solve a need for the customer. It indirectly solves it through providing tools for the feature team to do their job, but we see value in not introducing teams that are not directly connected to the customer.
I see. So sounds like the benefit of micro frontends is twofold. One is in the organizational structure and communication, reducing communication needs across multiple teams, but also you see value in having each team actually have a complete customer focus, which pushes them to build better product. Is that is that where you're getting at?
Yes, in many projects, we are doing the creating direct value for the customer reason is one of the main arguments.
So let's talk about CI/CD. I suppose having the entire team focused on one area actually helps with the testing, integration, and deployment as well. Do you want to comment on that?
Yes, so in practice, all teams have their own CI/CD pipeline. So when they make a change, they test their part of the user interface, and the pipeline also rolls out the new software to production. And these pipelines shouldn't be connected in any ways to ensure the independence. There might also be need for testing the interfaces between the teams. So having testing the customer journey, for example, going from the homepage to the product page to through the checkout to the confirmation page. But these types of tests where you have to ensure that everything fits together are not as many in our project. So all teams test their own application, and maybe they test the system they integrate with directly, but we don't see need for having a massive amount of cross team testing.
What about the ownership for production support? Does that then lie with the micro front end team as well?
Yes, when you go the full stack approach, so having a team being responsible from user interface to the database, they are also responsible for running their own system. So we implement a you build it, you run it approach where if something goes wrong on the weekend, someone from the team is paged and has to fix the problem to get it up and running again.
So it sounds like the push to micro front ends is multifold. One is organizational structure, reducing communication, increasing independence, allowing for customer focus for every team. Then the last one is just in the CI/CD pipelines, much easier to slice it vertically and then support it as well in production. So there seems to be a lot of benefits. Before we go on to the technologies, what are the cons?
So compared to a monolithic application, doing this vertical end-to-end split requires a lot of coordination. You have to find the right boundaries. You're suddenly running a distributed system, which is far more complex to run than just having one front-end team and one back-end team, for example. You're introducing technical complexity to achieve more development speed.
Okay. We'll get back to some more discussion on the pros and cons in a bit, but let's talk about technology. So you started to say you're adding technical complexity. So how are these multiple micro frontends now fused together to form a cohesive application? Let's start with that. What are the options to do that?
Yeah, so the front-end integration part is where it's starting to get interesting. So that Microfront is not a specific technology and doesn't require a specific technology. And the technical solution you need for integrating the user interface heavily depends on the application you're building. So if you're building a server-side rendered application, maybe a Ruby on Rails application, you need a service or a piece of infrastructure that takes the HTML snippets from the different teams, composes them together, and delivers them to the end user. So the end user sees its complete picture with the user interface parts from all of these teams. If you're running a fully client-side rendered application, like having multiple teams developing different React applications that should be integrated in the front end, the solution is quite different. So you don't need server-side markup generation because markup is only generated on the client. So if you're generating your markup on the client side, maybe with having multiple teams developing React applications, these teams would integrate client side. So a solution that you could use would be web components, for example. So having the user interface from one team being wrapped in a web component and having the web component be the contract for the other teams. So if you're rendering your markup on the client side, you would also do the integration on the client side. So you would have multiple teams all developing their own React applications or small UI parts that are React applications in and of themselves. And these teams would have to come up with a contract to use the user interface from another team. And a good way for doing this would be to use web components as a technical standard that all teams can agree upon.
Let's go slowly. You talked about server side rendered, and with an example of Ruby on Rails, and then you talked about teams developing with React. Is it possible, first of all, that you have some teams developing with the server side rendering technology and some with JavaScript and React?
Yes, you can, of course, mix and match these approaches. So having one team only doing client-side rendering and another team doing server-side rendering, as long as your integration techniques support talking to each other.
So let's talk more about web components. How are the requirements for the web components defined? And what if the needs change? The teams then still have to communicate and coordinate with each other?
So we are using web components as a neutral integration format which you can expose your application in. So let me give you an example. Maybe we have a team which has the job of delivering a recommendation strip that other teams can use inside of the e-commerce system. And this team creates a web component which it registers globally inside of the browser, and the web component and this team, the recommendation team, tells the name and maybe attributes you can pass into this web components to the other teams. And as long as the name of the web component and the attributes, so the signature of the web components, don't change, both teams are free to develop, evolve their parts of the application. So the recommendation team can implement smarter algorithms, do a nicer view of the recommendation strip, for example, and they can do everything they want as long as they don't change the interface, so the technical API between these teams.
So web components are one way of composing from front ends from multiple teams. What are the other ways of composing the UI? Let's start with server-side rendered applications.
Yeah, so with server-side rendering, there are different options. So I've seen companies building their own assembly proxy, so having one team deliver a page, but this page is not complete, but it requires insertion of markup fragments, so we call them fragments, from other teams. And all the markup that's generated server-side passes through this assembly service, which looks for the placeholders and fetches the markup from the other teams and then delivers the complete page. You can do this with standard Nginx by activating its SSI feature, which does this concatenation of markup. But there are also other solutions, like folks from Zalando, the German retailer, developed a tool which is called Tailor. And there are other libraries like Podium, for example, which also do this assembly. And if you're using a CDN, most CDNs implement a feature which is called ESI, which is quite similar to the SSI feature I talked about in Nginx, which also does this assembly, but on the edge. So just before your pages are delivered from your content delivery network, the other fragments of content are fetched and moved in and assembled.
What does SSI stand for?
SSI is short for server-side includes, and ESI is short for edge-side includes. So one happens on the server, on your web server inside of your data center, and the edge-side include is more of a CDN feature.
So in both these cases, as well as web components, we are still talking of a single page that has UI from multiple micro front-end teams.
Yes. So when we're talking about assembly, or when we're talking about composition with SSI, for example, or with web components, we are talking about how to integrate user interface parts from multiple teams into one view. But there's also another type of integration, which is called routing, where you integrate between pages of different teams. So as in my example from earlier, when you're building an online shop and you have a checkout team, for example, and you have a search team, these teams, the largest part of their team UIs are individual pages. So you have the search page, the checkout team maybe as a cart page and payment pages and other pages. And to integrate on page level, you need to use routing. So a classical server way would be to have a load balancer or having something like Nginx, which does URL-based routing. So all URLs starting with search, for example, go to the search team. All URLs starting with checkout go to the checkout team. This works very well when you're generating server-side, but if you're trying to build a unified single-page application, so having a single-page application which consists of multiple single-page applications inside of the browser, so having a single-page application from Team Checkout, having a single-page application from Team Search, you need to teach the browser a way to move from one single page application to another single page application without doing a hard reload. And there are also libraries that implement this routing on top of single page applications. The most popular one is a library which is called Single SPA.
Hiring a software engineer? Then we recommend working with G2I. G2I is the most effective way to discover talented and pre-vetted engineers for every project. G2I vets their talent pool through technical interviews and various code challenges which are graded by actual engineers, saving you time and guaranteeing you top quality through their transparent grading. They specialize in React, React Native, and Node.js. Interested in learning more? Then go to g2i.co.
Okay, all right. So one single page can have fragments from different micro frontends teams. Multiple pages, there can be routing between multiple pages where the browser refreshes, it just loads the new page. And then the last option is when you're trying to actually put together multiple SPA applications together, and you do not want the refresh of the browser. Are those three things that you talked about?
Yes.
Okay. So web components is for composing potentially one page with multiple fragments. And on the routing, now on the server-side rendered applications, let's talk about the technical option to support the routing and navigation between these. Do you need to introduce additional framework to allow for that routing?
Okay, so doing server-side routing requires all requests going through one central place which does the routing. So when you want to do the routing on a path base, so all URLs starting with one prefix go to one team, and all URLs starting with another prefix go to another team, you need a single piece of infrastructure that handles this and also contains this routing logic, which prefix is responsible for which team. We call this in layer a frontend proxy in our projects, which can be a standard Nginx web server, for example, or with a configuration for these different paths.
And in the case of multiple single page applications that come together, how do you still integrate so that the experience does not degrade?
So if we move the routing to the front end with a library like single SPA, for example, the routing logic suddenly moves to the front end and you introduce a single point of failure. So all incoming requests go to what we call an application shell. So having a minimalistic HTML file with this routing logic, which knows, okay, when the incoming URL starts with this prefix parameter, I have to load the single page app from one team, instantiate it, so it comes to life. And if you break this application shell, and if this application shell fails, the application doesn't work. The complete application doesn't work anymore. So we introduce a single piece of infrastructure, which is quite critical, and someone has to own and maintain this application shell.
And I suppose one of the Microfront teams would have to own up and support this shell as well.
Yes. Or if you go with the platform team, maybe the platform team hosts this. But yes.
What is the approach that you've taken in your projects?
So in our projects, we go with an approach we call linked single page apps. So each team can develop a single page app. You may have a single page app for the checkout, for example. But when you cross team boundaries, so when the team goes from search to the product page, they do a hard reload. So the user interface inside of the search can be client-side rendered and quick, but moving from one team to another introduces a reload, which if your application renders quickly might not be a huge negative impact to your customer.
So, what was the evaluation process for you to choose this approach versus having it more complex?
So as we work in e-commerce, it's crucial for us to deliver fast page load speed. So server rendering is quite important for the product page, product list pages, and also search engine optimization was a very high goal. So this leads us to opting for server rendering, and at least in the projects we've built up until now, the complexity of introducing a shared application shell on top of server-side rendering, so having universal rendering with an application shell, introduced a high amount of complexity, which we avoided. We opted for a simpler approach with linked single-page applications and didn't implement the application shell.
Okay, Michael, but let's introduce a little more context on universal rendering. You talked about a new term there. Please help us understand what you mean by universal rendering.
Yeah, so the term universal rendering or isomorphic applications, isomorphic rendering, isomorphic JavaScript describes a technique where the front end can be rendered in the client, but you can use the same code also running on the server. So modern JavaScript frameworks call this feature server-side rendering as a feature for a JavaScript application, for example. Teams in our projects can opt to also do server-side rendering on top of client-side rendering to get the benefits of a faster first page load, for example, and being able to be indexed by search engines better.
Let's talk about events a little bit. Are there use cases that require microfrontends to react to events from another microfrontend?
Yeah, so communication is also an important topic. When we are talking about the on page level, you have communication via the URL. So you have a search page, and the team owning the search page has to know the URL scheme for the product detail page. So they add an SKU parameter to the URL of the product page, and this is already a kind of communication. So communicating via URL. This is a really RESTful way of communication. But when you have multiple user interfaces from different teams on one page, you sometimes also have the need for talking across these user interface parts. So let me give you an example on a product page. You may have a product page with a buy button, and the buy button is owned by the checkout team. So when you click the buy button, the checkout is modified But you may also have other user interface elements or other fragments from the checkout team on the same page. So you might have a mini basket. So if you click on the buy button for a product, you want the mini basket to reflect the change, but both UIs are separated. So you have one micro frontend showing the button, you have another micro frontend showing the mini card, and you need some kind of communication between those two. And a system you could use, which is already present in all browsers, is using custom browser events. So like emitting a click event, you can emit a specific event for the use case the user just did. So the button can emit a product added to basket event, and other microfrontends can listen to it and react.
Okay, so let's summarize here. There are many ways to compose the application from UI from the multiple micro frontend teams. You could have web components that contribute to a single page. You could do routing between multiple pages with hard refreshes using links. You could also have some kind of shell layer then that can integrate with multiple single page applications so that there is no need to do a hard refresh when you're navigating between micro frontends. However, that does introduce that additional layer. The last thing we talked about was events and the ability to potentially react to events between different micro frontends as well. Is there any other topic for the technology aspect that you'd like to cover?
From a front-end integration perspective, I think we covered all of them. So having routing, having composition, and also having strategies for doing communication. So in practice, you might also need, we talked about authentication before. You need a common way for all teams to access login information, for example. Or maybe you want to introduce central headers, for example, that indicate which country the user is in or which environment your application is deployed to. So there are the context information that might also be interesting to think about before you're building an application.
So let's move into the more discussion on the pros and cons. We did talk about the pros and we'll come back to that. What about more on the cons? Let's talk about performance. Now you have multiple deployments and you have navigation and routing. Can you talk about what this means to performance?
Yeah, so when you're integrating on the server side, and you don't have much client-side code, I think the performance aspects are negligible. So you need a server-side markup concatenation, which should be fast, but the overall load time of the page shouldn't be different from a page which is built by a monolithic application, for example. If you're doing the client-side integration part, where all teams use JavaScript frameworks or maybe use different JavaScript frameworks, you introduce overhead. So the browser has to load the vendor code, the React runtime, for example, for all of these teams. And you have different options of going with this. So most projects I've seen, all teams agree upon one standard way or one standard framework to use. So unless one team has some very serious reason to deviate from the standard, all teams use, for example, React. And then it becomes easy to put the React runtime or multiple versions of the React runtime inside of a shared CDN, for example, and let teams link to it. And if multiple teams use the same version of React, for example, it's only downloaded once and not downloaded for every micro frontend. So this is one way of achieving or of improving the performance and reducing the overhead. And another quite interesting trend is that over the last years, we've seen front-end frameworks that don't introduce a runtime at all. So frameworks like Svelte, for example, or Stencil are frameworks that don't have a large runtime, as you know from React or Vue.js or Angular. They just compile to very straightforward JavaScript code, which grows linear to the amount of features you build. So if you're building a Hello World application in Svelte, the JavaScript associated with it is very, very small. And if you have multiple teams building microfrontends with tools like this, there's not much extra overhead compared to a monolithic application.
So the overhead you talked about was mainly around the amount of JavaScript that has to be downloaded. And potentially when you're navigating between multiple micro frontends, you would be downloading that JavaScript multiple times. using new frameworks like Svelte, which have much reduced amount of JavaScript, automatically helps. That was your point.
Yes. There's also, if you want to achieve isolation on style level, you also talk about redundant CSS or styling code. So if you're having a pattern library and all teams pull their CSS for a button, for example, from the pattern library, prefix it and bundle it in their own style sheet, you also introduce redundant styles. But in practice, this is not a huge issue when it comes to load performance, because browsers are able to parse CSS very fast. Browsers are able to process CSS in a very fast way compared to the overhead JavaScript introduces.
What about usability cons? So you did talk about one where potentially navigating between multiple microfrontends requires refreshes. What other impacts to usability have you observed, and what are some ways to mitigate it?
Yeah, so having a shared design system and having a good concept for user experience that all teams adhere to is very critical. So as I said, we introduce a design system with all Microfrontends projects we do, because changing the user experience or changing the UI a couple months later to unify all of the user interface parts is quite a challenging job. But yes, you have the challenge that multiple teams build applications in their own way, and you have to talk about, should the submit button be on the left side, on the right side, should the labeling on the button be capitalized or not, and you have to define these aspects more thoroughly compared to a monolithic application where you have one team and the team implicitly knows how to do stuff. And in this way, you wouldn't have to have a widget or have a solid documentation on it. And
So it is certainly important for the different teams to talk to each other, to understand the different design patterns in this case. And we did talk about that earlier. You mentioned that you encourage weekly guild meetings. Is that the term you used?
so the team guild or guild meetings, where people from the same profession but from different teams come together, is a term, I guess, Spotify introduced a couple of years ago. Maybe we can add a link to the show notes. They have a quite good documentation on their team structure, which is quite similar to what we now call Microfrontends. So they had an organization which is structured quite similar to the things we just talked about in the Microfrontends concept, but they did it much earlier and shared their experiences with it. And one of these learnings is having people from different teams connect with each other, helps building better products.
Is it ever a good idea to start with a Microbrunten based approach?
All projects I know that implemented microfrontends come from at least an earlier system, mostly a monolithic system, where the developers and architects that work on it had a very good understanding on how good cuts and good boundaries could be established inside of this application. So if you're a startup and you don't know how your final product will look, I think it's not helpful to introduce a microfrontends architecture with these solid boundaries that are organized around. So I think it's not a good idea to start with a microfrontends architecture. So if you're a startup and you don't know how your final product will look like, maybe you have to change plans along the way, I think implementing a microfrontends approach can stand in your way, because you might have to change team boundaries a lot of times as your product is changing. And changing team boundaries is something which is very complex and very hard to do. So the microfrontend architecture optimizes to create value inside of these boundaries, but I would only implement it when you're confident about your boundaries.
That said, how do you start maybe with the monolithic front end, but with the recognition that in the future you might want to refactor to a micro frontends architecture? What principles do you have to keep in mind in that case?
Yes, so even if you start building a monolith, structuring your monolith in a way that acknowledges boundaries and even if you start with a monolith, you can modularize it in a way that makes it easy to do a hard cut later on. So divide your monolith into two different systems along the line of split up your monolith in the middle, for example, and having one set of pages be in one application and another set of applications be in another part of the application, and maybe figure out which parts should be fragments that the other application needs to integrate. So it's definitely possible, if you have an eye on the structure from the start, to create an application which is easier to split later on.
So, being aware of the functional boundaries, that makes sense. What about in terms of the infrastructure or technologies that they adopt? Is there any guidance?
So since the Microfrontends architecture doesn't make any assumptions on if your application is server-side, client-side, or what framework you're using, I think you're pretty good. You're pretty open to using the best tool for the job, and later on find an integration solution that fits your approach.
Are you aware of any cases where people did build with microfrontends and then realized that that might have been a mistake or an overkill?
I've read a blog post from a gaming company. I don't know the name on top of my head, but they introduced a microfrontends application a few years ago, and it didn't have strong guidelines on what tech stack these teams could use, and they had massive issues with having a lot of JavaScript being loaded for all users, which resulted in a very slow user experience. And they moved away from this microfrontends architecture to a more monolithic approach to solve these issues.
So it certainly sounds like, the overarching goals is team independence, letting people choose their own technologies, letting people manage their own application, part of the application, end to end. However, there are other needs to communicate between teams to ensure that the design is consistent. There are some cons with respect to paying a lot of attention to ensuring that the performance is adequate and the usability is adequate. Anything else you want to summarize this section with on the pros and cons?
I think it's a pretty good summary of the important parts of the microfrontends architecture.
So, Michael, let's talk more about your book. What were your goals in writing this book?
So as we started building our first applications following these architectures, so back in the day, I think in 2014, we did our first project. And at this time, the term microfrontends wasn't around, and there was nothing to Google for solving an integration of multiple applications and what challenges this introduces. So with the book I've written over the last year, I'm trying to address all of the things we learned the hard way in our journey on building different applications using this architecture. And yeah, so you could say the book I've written is the book I wanted to have back then in 2014 when we got started. So I hope there are lessons in there are techniques in there that can help other people who want to adopt this architecture, so that they don't have to solve the same problems from the start, but are aware of some pitfalls and see solutions for the challenges they come across.
I noticed you had a lot of code samples in your book. How are you expecting readers to use those code samples?
Yes. So as a developer, I love code, obviously. And throughout the book, you're building an e-commerce application. So we start with a pretty simple product detail page and expand this product detail page by adding new features, introducing new teams, introducing communication patterns, for example, but also solving performance issues. And the sample code for this book is available on my GitHub repository, but it's also hosted on a site which is called the tractor.store, which we can link in the show notes. And as you follow the chapters in the book, you can run your code on your machine, but you can also go directly to the browser and just play with the end result to get a feeling of what parts are involved in creating a microfrontends application, and not only hearing about theoretical concepts, but also playing around with it, modifying it, and moving on from there.
When is your book expected to be available?
So the book is currently available in early access. If you sign up for the book, you can read all of the chapters, and we are currently in the production stage, so getting everything ready to be printed, and it should be out this summer.
We'll definitely have a link to your book in the show notes. Is there anything that you've covered in the book that we haven't talked about today?
The book goes into detail on some technical optimizations like doing asset delivery and providing caching, and also some optimization strategies for performance. But as of the topics we just talked about, I think we covered the big picture and talked about all of the important aspects.
Michael, how can people contact you?
They can follow me on Twitter or on GitHub under the name Naltatis. And I'm also running a site which is called micro-frontends.org, where you can learn more about the Microfrontends architecture.
We'll include a link to the website on the show notes. It was really great having you here today, Michael. Thank you so much.
Thanks for having me.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.